Hello friends, welcome to the next session. Here we are going to study the distinguish between deterministic finite automata and non-deterministic finite automata. Now coming on to the first point of the distinguish. When I talk of deterministic finite automata, we just now discussed that in DFA, from each state on each input symbol, there is going to be exactly one transition. Whereas in NFA, from each state on each input symbol, there can be 0, 1 or more than one transitions. So that forms the first point of the distinguish. So here I say, from each state on each input symbol, there is exactly one transition in case of my deterministic finite automata. Whereas in NFA, there can be 0, 1 or more transitions in case of my non-deterministic finite automata. The next point of distinguish is going to be our transition function. The transition function for DFA is given a state and an input symbol, what is the next state? So we write it as Q for given a state, summation for the input symbol, and for calculating the next state we represent it by another Q. So Q cross summation gives me Q. Now coming on to the NFA. So in NFA we say the transition function over here is given a state and an input symbol, the output over here is 2 raised to Q. So till now I have not explained you what is exactly 2 raised to Q. So let's go to this particular point in detail now. So when I talk of 2 raised to Q, we define this transition function as given a state and an input symbol, what are the possible states of output. So in NFA we know that there can be 0, 1 or more outputs. So in case if the outputs are 0 or 1 or more than 1, if I count the total number of outputs that is possible for a given NFA, they are always going to be in the power of 2. That is, let us say if I have 2 states, the possible number of outcomes are always going to be 2 raised to 2. If there are 3 states, the possible state of outputs are going to be 2 raised to 3, that is 8 outputs. That is, there can be a maximum of 8 outputs in this case, where the NFA can ideally have 0 output shown or 1 output shown or at the max 8 outputs, but it can never exceed it. So that's exactly what it means. Given a state and an input symbol, what are the possible states of output? Moving on to the third point of DFA versus NFA. Now here we say the implementation of DFA with the help of a computer program. By this I mean to say, if we are implementing a deterministic finite automata with the help of some coding language, let's assume for now as a C programming language. So the implementation of DFA with the help of the program is going to be very simple. And what is the reason for its simplicity? It's deterministic nature. So I say the implementation of DFA with the help of a computer program is going to be simple. Whereas if I observe the third point, in case of NFA, the implementation of NFA with the help of a computer program is going to be complex because of its non-deterministic nature. So I write over here, the implementation is going to be complex because of its non-deterministic nature. And by now we all know what is non-deterministic. The output is going to be really unpredictable because it can have more than one outputs for a given input symbol. The next point we can see in slide number 4. In case of DFA, I can say my every DFA is going to be a NFA. Let me write it first. I say over here that every DFA is always a NFA. If you understand this point clearly, in DFA from each state on each input symbol there is exactly one transition, whereas in NFA there can be 0, 1 or more transitions. So gradually grasping this definition, we understand that DFA is actually a subset of NFA, because DFA allows only one transition, whereas NFA allows 0, 1 or any number of transitions depending on the number of states available. Therefore, we say DFA is always a NFA, whereas the vice versa case, NFA in case of DFA. Wait, don't frame the definition in your mind as every NFA is not a DFA. I say NFA may or may not be a DFA. Just assume a NFA in which we are having from each state on each input symbol exactly one transition. So only in that case my NFA is going to be a DFA. Whereas in all other cases which are written in the transition table, it is never going to be a DFA. Therefore, I say my point number 4 in case of NFA is NFA may or may not be a DFA. The next point number 5. In DFA, we cannot have epsilon transitions. We have just now solved the problem on DFA and we saw that there are no epsilon transitions. However, when I come to NFA problems, till now we have not considered epsilon transitions. However, NFA allows epsilon transitions, and that is exactly what we are going to study in the next video. So over here, just assume this point for time being, that in NFA, I can say we may or may not have epsilon transitions. The example which we just saw before did not have any epsilon transition, whereas the further examples are going to have it. The last point number 6, is going to be the example of DFA and NFA, which we have done exactly in the previous video. So whenever a distinguish between DFA and NFA comes, my distinguish should be populated with these 6 points. With this, we finish with the distinguished. See you in the next session. Thank you.